So for the word problems in Chapter 6, Section 4, number 23 is a little bit like this. Fred walks 3 miles an hour and John walks about 4 miles an hour, but John started 2 miles behind Fred. Will they ever meet? So Fred is walking 3 miles per hour, where X is hour and Y is how far does he walk. And John started at 4 miles per hour, but he started 2 miles behind, which is a -2 in his sentence. And the question is, will they ever meet? So we're going to set this part of the equation to equal this part of the equation and solve for X so that we can find out if there is an X that works for both of these, so that when we plug it back in, we can solve for both an X and a Y. We can say when they will meet. Okay? Problems like number 24 and 27. Photocopier A makes 35 copies a minute, and then we start A. And then photocopier B starts 10 minutes behind that. It also makes 35 copies a minute. You're going to write an equation just like we did up here, where this is going to be your X, 35 times X, and 10 minutes behind is just like we did here. So start your two equations, and the question is, will they meet? And you need to explain it mathematically. And you can use the mathematical words that we've been using, but I need them to be as exact as you can, okay? Problems like 25 and 26 are that Fred bought 2 popcorns and 4 sodas at last week's movie, and he paid $24. And this week he bought 3 popcorns and 2 sodas for $18. Find the cost of each. So we're going to make one of these X and one of them Y, and it's going to be the same X and Y as this one. So X is always popcorn and Y is always soda. And so we've got 2X plus 4Y is 24. 3X plus 2Y is 18. And so we're going to solve for Y. So we're going to do -2X minus 2X. And then 4Y equals -2X plus 24. And then we're going to divide each by 4. So that X equals -1/2. Nope, that's a Y. Y equals -1/2 X plus 6. Then we're going to solve here. I don't know if these numbers work. I made them up. But you're going to solve for Y here, and then you're going to take this half of the equation equals this half of the equation, put them together, solve for X, and then put that back in to solve for Y, so you know how many each of them is. And this works for both numbers 25 and 26. Okay? Okay, so in 28, it's given us 2 different data tables. And the first thing it asks us to do is write the equations. And these are different data tables, but it gives you the same general idea. How do I get from X to Y? Is times 2. And how do I get from X to Y? That's times 2. And how do I get from X to Y? That's times 2. So we're always saying 2 times whatever X is going to give us Y. I don't have to add or subtract anything in order to get there. Looking at this one, this is also times 2, times 2, times 2. So this is also Y equals 2X. If I'm going to graph them, look, I end up with the same line. So when I describe this, it's going to be the same line. Can I predict the graph? Yes, it's going to be the same line. And I can tell you that it goes through 0.00 because it doesn't have a y-intercept, that it's going to go up 2 and over 1 when I draw my line. And they're both going to be identical. And then you get to D. What if each y value in the second table increases by 1? So instead of going 20, 22, 24, what if y was 20, 21, 22, 23? Would that change things? How does this affect the graph of the 2 equations? Well, it doesn't change this one at all. How does it change this one, though? How can you tell the graphs would be affected without actually graphing it? So without graphing it, can you tell me what's going to happen to it? okay? And you might have to graph it in order to see it for yourself, and then hopefully you can make those connections, okay? That's all we have for this section. If you have any additional questions, please find me so that I can walk you through them. Otherwise, I'll see you tomorrow.